In April 2026, quantum computing accelerated its leap into the real world. The conversation has shifted from theoretical physics to multi-billion-dollar buyouts, hardware breakthroughs, and a serious wake-up call for global cybersecurity. In this video, we count down the top 3 quantum computing events of April 2026. I'm George Geis, and this is a Quantum Computing Watch Briefing. All right, I have launched a visual application that tracks companies, relationships, and events in the quantum computing market. Let me use a prompt to bring out key company events in April 2026. What comes back is a scene with significant companies having major events. Those are the blue nodes. Here, let's take a look at some of the companies. Here's SkyWater. You may know that as a photonic company. Here is Inflection. Here is NVIDIA, of course, a major player in the space. Here is Rigetti Computing. Here is Xanadu. Here is Amazon. Here is Microsoft. You get a sense. But we want to focus on events related to 3 large company nodes. So let me go up here and select the first large company node. That has to do with QuEra. QuEra and a fragility problem. So coming in at number 3 on our countdown is a breakthrough from a private company called QuEra Computing. To understand why their announcement this month is such a big deal, we first need to understand quantum computing's biggest enemy, and that is noise. Traditional computers run on bits, ones and zeros. Bits are stable. If your computer saves a photo, that photo stays the same. Quantum computers, however, use qubits. Think of a qubit as it's kind of like a fragile soap bubble. They can hold vastly more complex information than a standard bit, but the slightest interference, a change in temperature, a stray electromagnetic wave, or even cosmic rays can pop the bubble and destroy the data. For years, the proposed solution has been error correction. The idea is to group hundreds or even thousands of these fragile physical qubits together to create just one reliable logical qubit. It's like needing 1,000 people just to successfully carry one delicate glass of water across a room. Because of this massive ratio, experts believed we would need to build quantum computers with millions of physical qubits before they became truly useful. And that would be an engineering nightmare. But in the past April, just this past April, QuEra published a paper that completely changes the math. They demonstrated that by using their neutral atom technology, they could build a highly reliable logical memory qubit using just 2 physical qubits. That's an unprecedented 2-to-1 ratio. While this breakthrough currently applies only to the computer's memory, it proves that we might not need millions of qubits to build a single world-changing machine. The finish line, well, it just got closer, keeping neutral atom technology right at the forefront of the quantum race. All right, so let me go down to the second large company node, and let me select it and expand it. And you'll see this one deals with IonQ. And it could be called IonQ buys the factory. So moving on to number 2, we have a major business move from IonQ, a company that saw its stock price surge over 50% during this past April. It's a very volatile company, as you may know. IonQ took a major step forward by filing its regulatory paperwork to advance a $1.8 billion acquisition of SkyWater Technology, a major semiconductor foundry. It's cash and stock offer. Why is this our number 2 event? Because it marks the moment a quantum computing company decided to completely control its own destiny. Until now, almost all quantum hardware companies designed their chips in-house, but had to rely on third-party foundries to build them. This is like designing a revolutionary new car engine, but having to wait in line to use a competitor's factory to build the parts. Slows down research, risks intellectual property theft, and leaves companies vulnerable to a global supply chain issues that may come up. By spending $1.8 billion to buy SkyWater Technology outright, IonQ is bringing its manufacturing process in-house. They are no longer just a research and design firm. They are a vertically integrated manufacturer, or they will become this. This allows them to build and test their quantum processors at record speeds. It's a flex of financial muscle that separates IonQ from smaller startups still waiting in line to get their chips printed. All right, let's go back and pick up number 1 on our list. And to find that, we'll go right up here and make a selection. This is Alphabet. So we could call this Alphabet Sounds the Security Alarm. So we reached number 1, the most significant event in quantum computing for April 2026. An event that doesn't just matter to scientists or investors, but to every single person who uses the internet. The top spot goes to a terrifying realization. Our global cybersecurity systems are under far more immediate pressure than previously assumed. To understand why, we need to talk about how the internet stays secure. When you send a message, log into your bank, or access medical records, your data is protected by encryption. Mathematical problems so complex that classical companies would need millions of years to break them. 30 years ago, mathematician Peter Shor proved that a sufficiently powerful quantum computer could break this encryption instantly. This theoretical threat, which is sometimes called the quantum apocalypse, has driven governments to prepare long-term defenses. The U.S. Set a 2035 deadline for federal systems to migrate to post-quantum cryptography, assuming that a code-breaking quantum computer was still many years and millions of physical qubits away. But heading into April 2026, that confidence was shattered. Simultaneous breakthrough papers from Google, Alphabet, Quantum AI, and the neutral atom startup Oratomic introduced staggering algorithmic and architectural optimizations that drastically reduced the resources needed to run Shor's algorithm. Google demonstrated that the encryption protecting systems like Bitcoin could be broken in just 9 minutes using fewer than 500,000 physical qubits. Meanwhile, Oratomic proved the system could do the same in a matter of days using as few as 26,000 atoms. While they didn't break real-world encryption today, they closed the gap between theory and practical threat by orders of magnitude. So what's the result? The result? Major internet infrastructure companies in April immediately accelerated their internal defenses. For example, Cloudflare and Google publicly emphasized the urgency of migrating to post-quantum cryptography, with both companies officially committing to aggressive internal deadlines to complete their PQC transitions by 2029. Well, this is the most significant event of the month, and possibly the entire year, because it reframes quantum computing from a distant concern into an urgent present-day crisis. The risk of attackers harvesting encrypted data now, simply waiting for these much smaller quantum machines to come online in a few years to decrypt it, that means the world cannot wait. These breakthroughs didn't break the internet's encryption, but they lit a fire under the global economy to prepare for the exact moment that they can. Okay, there you have it. April 2026 was the month the quantum landscape shifted beneath our feet. We saw QuEra prove that you don't need millions of fragile qubits to build reliable memory, drastically shortening the engineering roadmap. We watched IonQ flex its financial muscle to literally buy the factory, taking full control of its own manufacturing pipeline. And most importantly, we witnessed Google and Oratomic prove that the quantum threat to our digital security is no longer a distant worry for the 2030s, but a matter of reality that we must face before the end of the decade. The quantum era is no longer arriving. It's already here. Thanks for joining me on this countdown, and stay tuned as we continue to post updates on what promises to be the most disruptive technology of our lifetime.